Hello and welcome to Software Architecture course. In this lecture, we are going to talk about unified process. And as a practitioner, you must have heard of Rational Unified Process, or RUP, or it's also called UP, Unified Process. This is a very well-known process that's adopted in the industry for software development. Very popular process, and possibly this is covered as a part of software engineering course. In this lecture, I'm not going to therefore talk about unified process in detail, but I will basically speak about or discuss that part of unified process which is related to architecture. But for that, we need to have some understanding of the rational unified process or unified process. So let's see what a unified process is. So while UML provide the necessary technology for OO software design, that's not enough, because when you give this tool, you also need to tell the developers to specifically instruct how to step by step describe the system and then go ahead, implement, test, and so on. Now this step-by-step instruction is basically the process which is called a unified process. It gives a framework to build the software using the UML. It's basically an iterative approach where the different features can be built in different iterations, and there are 5 main phases. So the first one is called the inception, then the second one is called the elaboration, third one is called the construction, fourth one is called the transition, and the fifth one is called production. Inception is about explaining the stakeholders about this project scope and why this project scope is there, why you are not adding additional features, why you have taken only this much. So this kind of justification is required. Then outline the use cases and the key requirements that will be there, and in fact these use cases and key requirements will be the main part of inception, which will basically drive the design as well as the design trade-off. So using this, one could basically have multiple architectures, and then one can reason about which architecture to take and so on. Plus, at this inception phase, the risks need to be identified, and one needs to prepare a preliminary project schedule along with the cost estimate. So this is the inception phase. Elaboration phase is primarily architecture and design. We'll look into elaboration and bit of inception. So this is a very standard diagram. I have taken this right now. It is available in Wikimedia, and it is also available in any of the standard textbooks. So I have taken the diagram from there. It basically shows different phases, and it shows how one can have multiple iterations here. So let's look at this diagram a bit. There are 5 phases, or at least in this example we are talking about 4 phases. First 4: inception, elaboration, construction, and transition. So these are basically swim lanes or columns. Inception is one column, elaboration is the second column, and so on. And there are rows. The rows are basically different activities like business modeling, requirement analysis, implementation, test, and deployment. So the important part here is that the business modeling part is maximum during inception phase, but it can go on till elaboration phase. It's not necessary that business modeling needs to end when inception is over. It can continue during the elaboration phase. Similarly, from the business model to requirement, it happens again, starts from inception, slowly picks up during elaboration phase. It goes on, but it never stops. You see that in construction also there can be some little bit of requirement that might come in. In fact, they are not major changes, but in fact small minute details, small micro level requirements might still come in during construction phase. That's an expectation, and then that's what typically happens. Analysis and design, which is basically the architecture, it mostly happens during elaboration phase. Implementation happens again towards the end of elaboration and then goes on during construction. Test happens just when the elaboration ends, construction starts, and it happens in different phases, or it happens in burst. For example, some tests happen during elaboration, then it stops, then again during construction some sort of testing happens, again it happens during transition. And you see that inside each swim lane or inside each phase, like elaboration, construction, there are multiple iterations. Like E1 is one iteration, E2 is another iteration, C1 is one iteration, C2 is another iteration, and so on, which is why it's called iterative development. Architecture is focused all the time. That's very important. As you see that architecture actually starts from elaboration, but it continues. It's not that architecture is completely over once elaboration is done. That's very important. Architecture is there all the time. So the whole activity starts towards the end of the inception phase, and it goes on with a lot more detail during elaboration phase. Now, in this context, one needs to understand something called a feature-driven design, where where the system is considered to be a collection of features, and these features are implemented one after the another. It starts during the inception elaboration phase, as I said. Mostly used, this feature-driven design is mostly used in the context of agile development. Nonetheless, you can basically follow this inception elaboration phase or this RUP structure or UP structure and still have agile development. Now, feature-driven design, can very well fit in this UP process. So the requirement capturing, which happens during inception phase, can be modeled as a set of features that need to be captured. A feature is nothing but a client-valued functionality that can be implemented and demonstrated quickly. So one needs to have a set of features. Some features will be implemented first, which are simple, easy to implement, and the more complex features will be implemented later on. So how you can basically write a feature using a template, basically it's like you can use this kind of English, like start with an action, then describe the result and who is doing it. Sometimes, for example, or who is the object which is going to be impacted by this. Example is that add is an action, then add what? Add a product, that's a result, to shopping cart. So essentially it is a shopping cart to which a product needs to be added. So therefore adding a product becomes a feature to a shopping cart, which is an object. Similarly, store the shipping information for the customer. Then customer is an object which is going to have the feature which is storing the shipping information. From this feature, how do you come up with architecture? Once you have the set of features collected, the similar features are grouped together into a module. Remember that module is basically its high level decomposition right from the requirement, and that time I said that once you have the requirement, first create a set of modules, and each module is kind of a functionally cohesive, meaning that each module you basically divide the system into a set of functional groups. Each module is going to do a similar features. The functionality that are going to be there in a module now will be basically similar in nature. You are not going to put some disparate functionality within a module. For example, if you are talking about a shopping cart, and shopping cart is a module, inside the shopping cart module you will never put functionality that's related to, let us say, customer billing. So for that you need to have a separate module. So which is what I'm saying here is that similar features need to be grouped together to form a module. Then this basically is nothing but a clustering. You are clustering these features, and each cluster becomes a module. So once you do it, you get the very first cart module structure. Recall the software architecture and views, and where we talked about the module structure. Essentially you do this set of steps and then basically get the module structure. Then of course, once you have the module structures, you have the features which are grouped together. Now you can go for decomposition, usage, and so on. Use case model. Use cases are used to describe the particular usage scenario from the user's point of view. Very important. That's part of the UML diagram. Create a basic use case diagram and elaborate each use case. That's the first step. Then how do you create a use case? In fact, to create a use case, you need to define a set of actors, meaning who are going to use this use case or who are going to be impacted by the use case. Then describe the scenario. So this description is bit structured. You describe the precondition which must be satisfied so that this scenario takes place. What are the main tasks in the scenario? What are the exceptions that can happen? And under that exception scenario, what the system is supposed to do? Then different variations in the actor interaction. Actor can interact with the system in different ways. What are these different variations? Now in this process of executing the task, this actor who is going to use the use case, what sort of information this actor is going to acquire when the actor is going to use the use case, or what will it produce as information? Will it change any information? this information needs to be described. Now, important part is that will the actor need to be informed about the change when this use case is executed? Is it important that when some changes happen in the information, should the use case inform the actor? Or what about different unexpected scenarios? Both expected as well as unexpected scenarios. Does the user want to be informed about that? This needs to be described in the scenario. Let's look at this module views again. So when you are using the unified process, then what you first create is called a set of analysis classes. Now, earlier I said the feature driven design, in which you group the set of features and you call that as a module. That's fine, but if you are using the unified process terminology, when you group those features and form a module, you call that as an analysis class. Analysis class is essentially a terminology that's introduced in unified process. Analysis class essentially is a module. So while you are creating module views, either through use case approach or through feature driven approach, identify what are the external entities, like the other systems, devices that are going to interact with the system that's going to be implemented. There are different things like report, letters, signals, then structures, main structure like sensors, four-wheel car, etc. So these external entities, different things, structures, they all are going to be analysis classes. Let's continue. Things like event occurrences, transfer of fund, completion of job, these are all the tasks or event occurrences, but they are important event occurrences which are going to contribute to different analysis classes. Different roles like people, actors of the use case like manager, engineer, etc., who are going to interact with the system, they will also be analysis classes. In fact, there will be some analysis classes which are going to represent a manager or represent an engineer, and most likely these analysis classes which are going to represent a manager or an engineer, for those representative classes you are going to have a user interface, because the actual manager is going to interact with the system through that user interface. So what I'm saying is that these things like manager, engineer, which are actors, each of them will be a candidate analysis class, and along with this there will be a user interface component. Different organizational units like divisions or groups that are important for the system, they will also be different modules, different places, the locations, the context information, that will also be possible, or different types of analysis classes. How do you get these classes? So by analyzing the feature description or by analyzing the use case description requirements, you basically collect the noun phrases. These are the potential objects. Now you can apply this set of heuristics to get a legitimate analysis class. For example, it should retain some information for processing. These noun phrases are just not casual noun phrases, but these noun phrases are doing some important activity. It is retaining the information for further processing. Then only it becomes an important analysis class. It should have a set of identifiable operations. They should implement certain operations, and you should be able to understand that by looking at those descriptions as well as noun phrases. For a particular class there should be multiple attributes. Without any attribute it is meaningless to have any analysis class. If you identify something to be an analysis class, then operations should be applicable to all the instances. You need to first analyze whether you are going to, if it is possible to have a scenario where operations are allowed only to a few instances but not all. In that case you need to rethink again and see whether this should really be analysis class, or you need to really break it into multiple analysis classes. Now again, the attributes that you are going to define for an analysis class, this must be meaningful for all instances. It can't be partially meaningful, or it shouldn't be the case that only for few instances these attributes are meaningful, but in some other instances these attributes are not meaningful. Then these attributes are not good. You haven't captured them well, or even the analysis class is also not good. So these are the heuristics that I have highlighted to basically describe the module view from the requirement. It's very important that requirement from the requirement and from the use case, you need to come up with the first cut, which is a module view. Only after module view you have to go for component and connector view and then the deployment view. So the module view is basically the first step towards architecture description, and these are the techniques to be used to come up with a module view. So that's it for this particular module. Thank you.